Hello everyone and welcome back to the video lecture series on radical expressions. Today we are going to be covering multiplication and division of radical expressions. So before we get into this, we need to recap some of the biggest properties of radicals, a couple of which we've seen before and one of which we have not. Give me a second. So the first one is the product property of radicals, which says that if you have a product inside of a radical, you can split it up into the product of two separate radicals. So you can take the square root of a times b and write it as the square root of a times the square root of b. Then the quotient property of radicals says that if you have a quotient or fraction inside of a radical, you can simply take the square root of the top and the square root of the bottom. Then for this next one, if you have a power associated with a radical, because they go in the same place in order of operations, they're somewhat interchangeable. So if you have the square root of some a to some power m, you can rewrite it as parentheses square root of a all raised to the power m. So what this means is that you can break up multiplication and division inside of a square root into two separate square roots. This rule does not work for addition or subtraction inside of a radical, so you cannot split up addition or subtraction that is inside of a square root. You can also switch the order of power. So for example, if you have the square root of 3 squared, that is the same thing as parentheses square root of 3 squared. In either case, whenever you have a square root and a square performed together, they will cancel out, leaving you with what was inside the radical. So we're just also going to review how to simplify square roots because we're going to be doing this periodically. Remember that the square root of a perfect square comes out to a whole number. If you have a square root of a not perfect square, what you're going to find is the largest perfect square factor of the radicand. Then you're going to write the radicand as a product and use the product property of radicals to separate it into the product of two separate square roots. You're finished simplifying when the radicand has no more perfect square factors. Now, if you have a variable to a certain power underneath a square root, remember that when your power is exactly equal to 2, the square root and the square will cancel each other out. Now, if your power is higher than 2, that means it can be simplified. So you will ask yourself, how many times does 2 go into that power? And you're going to write it in terms of as many x squareds as you can. Then, if the power on the variable is lower than 2, it cannot be simplified any further. So for this next one, what we're going to do is we have a product of two separate square roots. Now that product property of radicals can also work in reverse. You can take the product of two separate radicals and combine them into the square root of a product. So I'm going to combine these all into one square root. I'm going to combine this into the square root of 2x squared times 32x to the 5th. Then 2 times 32 is 64. And then I have this x squared times x to the 5th. Well, we know that any time that our power is exactly equal to 2, it will cancel out with the square root. Also, 64 is a perfect square, and that is going to come out to a whole number. And then for this x to the 5th, because that power is higher than 2, that means it can simplify. So I'm actually going to split this up into the product of 3 separate new radicals, and I'm going to work on simplifying. So I'm going to split this up into the square root of 64 times the square root of x squared times the square root of x to the 5th. Now the square root of 64 is 8, and then square root and square cancel each other out, leaving you with x. And then we have this square root of x to the 5th. And because this power is higher than 2, that means that we can simplify it. So I'm going to write this in terms of as many x squareds as I possibly can. So how many times does 2 go into 5? Well, 2 goes into 5 approximately 2 times. So I'm going to write this as x squared times itself 2 times, with an x to the power 1 left over. Then I'm going to write this product underneath the square root into the product of 3 separate square roots. So I'm going to write this as the square root of x squared times the square root of x squared times the square root of x to the power 1. So that leaves us with the 8x still there. Square and square root cancel each other out, leaving you with x. Then square root and square cancel each other out, leaving you with another x. And then for this x to the power 1, because that power is lower than 2, it cannot be simplified, so I'm going to have to just leave it as the square root of x. Then we're going to finish simplifying by multiplying everything that is not in a square root together. So this will become 8x cubed times the square root of x. And then this is our fully simplified final answer. Now for this next one, because there is hidden multiplication between that 2x and that parentheses, we're actually going to simplify this by distributing. So I'm going to distribute the square root of 2x to every single term inside the parentheses. And so I'm going to multiply the square root of 2x first by x, so square root of 2x times x. Unfortunately, you cannot multiply something that is in a square root by something that is not in a square root, so you're just going to have to leave it as x square root of 2x. Then we're going to take the square root of 2x and then we're going to multiply it to the next term, square root of 2x. So remember, whenever you have anything times itself, you can always rewrite anything times itself as a square. So I'm going to write this root 2x times itself as the square root of 2x parentheses squared. And then the same rules with square roots and squares apply. If you have a square and a square root performed together at the same time, they're going to cancel each other out, leaving you with what was inside the square root, 2x. So this will simplify as x square root of 2x, plus when those canceled out, you were left with 2x. Now, fortunately, these are unlike terms because this has a square root of 2x in it and this no longer does, so we're going to call this our final answer. Then for these next two, because there is multiplication between each of these sets of parentheses, we're going to be simplifying these using distribution again. And this will follow the exact same process as FOIL, which we learned earlier in the semester. So we're going to simplify these by distributing. So I'm going to multiply the first terms together. Square root of 2 times itself can be rewritten as the square root of 2 parentheses squared. Because remember, you can always rewrite repeated multiplication as a square. Then we're going to take the square root of 2, we're going to multiply it by x. Now because we are multiplying a square root by a non-square root, we're just going to have to leave this as x square root of 2. You cannot combine them any more than that. That's as good as it's going to get. Then when we multiply the inside terms together, negative 3x times root 2, and again, if you have a non-square root times a square root, you can't really combine them, so all you can do is write this as minus 3x square root of 2. And then negative 3x times 1x is going to give us negative 3x squared. And then we're going to simplify this. So over here, whenever you have a square root and a square performed together, they will cancel each other out, and that leaves you with 2. Now these middle terms are actually like terms, because not only do they both have an x in them, but they both have a square root of 2. These are like radicals. So because you have like terms and like radicals, we can combine these as we would any other like term. So 1x square root of 2 minus 3x square root of 2 is negative 2x square root of 2. And then over here we have this minus 3x squared. Now unfortunately none of these are like terms because we have 2, we have a 3x squared, and we have this 2x root 2. So none of those really have a whole lot in common, so because they are not like terms, that is as simplified as that's going to get. So we're going to do this next one. We're going to simplify this using distribution. So I'm going to multiply the first terms together. 3 times 3 gives us 9. Then 3 times negative square root of y. When you have a square root times a non-square root, you could just write it as minus 3 root y, and that's as good as that's going to get. And then for the inside terms, positive root y times 3. Again, you can't really simplify that much, so we're just going to write that as positive 3 square root of y. And then first off, for these last terms, positive times a negative is a negative. And then root y times root y, well, you can rewrite anything times itself as a squared. So I'm going to write that as the square root of y, parentheses squared. Then, whenever you have a square and a square root performed together, they're going to cancel each other out. And then these two terms in the middle are actually like terms because they are like radicals, square root of y, square root of y. So we're just going to combine them by adding the coefficients together. Negative 3 root y plus 3 root y is 0. And those, in fact, cancel each other out. So then we are left with this 9. Don't forget that minus sign. And then when that square root and square cancel each other out, we were left with y. So 9 minus y is now our fully simplified final answer. Now, the rule that you cannot distribute a square across a plus or a minus sign still applies here. So what we are going to have to do with this first is that we are going to have to expand it. If you remember from chapter 4, expanding means we're going to take this exponent of 2 and we're going to rewrite it as repeated multiplication. So I'm going to write this as the square root of x minus 2 times itself, parentheses, square root of x minus 2. And then I'm going to simplify this by foiling. So I'm going to multiply the first terms together, square root of x times itself. Anything times itself can be written as a squared, so I'm going to write this as the square root of x, parentheses, squared. Then x times negative 2, we're just going to have to write that as negative 2 root x, and that's good enough. Then negative 2 times the square root of x, again, we're going to just have to write this as negative 2 root x. And then for the last terms, negative 2 times negative 2 is positive 4. So then let's simplify. Over here, when the square root and the square cancel each other out, we are left with x. And these two terms in the middle are actually like terms because these are like radicals. So negative 2 square root of x minus another 2 square root of x is minus 4 square root of x. And then we have this plus 4 here on the end. And none of these are like terms, so this is actually fully simplified. Now, for working with quotients or fractions that are inside of a radical, we're going to use the quotient property of radicals. So here's how to take the square root of a fraction. Whenever you have a fraction inside of a square root, you can simply just take the square root of the top number divided by the square root, the square root of the bottom number. So then, since we can do each of these square roots, we're going to evaluate them. So the square root of 1 is 1, and the square root of 4 is 2. So the square root of 1/4 is actually 1/2. Now for this next one, anything that is inside of a square root, you should really think about, there's implied parentheses around there. So if you have any of the same base that is inside of a square root, you should really combine those first and then worry about the square root part. Now, we don't have any of the same bases here because we have a 4x squared over z to the 6th. So we've got all different bases. So since there's actually nothing that we can combine inside the square root, we're going to work on splitting up the square root and simplifying it piece by piece. So I'm going to split this up into the square root of the top expression, square root of 4x squared, divided by the square root of the bottom, square root of z to the 6th. Then if you take a look on the top, this 4 is a perfect square. X squared is also a perfect square. So I'm going to separate that square root on the top as the product of two separate square roots. I'm going to split it up into the square root of 4 times the square root of x squared. Then on the bottom for this z to the 6th, since this power is higher than 2, that means it can simplify further. So how many times does 2 go into 6? Well, 2 goes into 6 3 times. So I'm going to write this as z squared times itself 3 times. Then on the top, I've got the square root of 4 times the square root of x squared. And then on the bottom, I'm going to take this product underneath the square root, and I'm going to separate this into the product of 3 separate square roots. So square root of z squared times another root z squared times another square root of z squared. And then I'm going to evaluate all of the square roots that I can. So the square root of 4 is 2. Square root and square cancel each other out, leaving you with x. And then on the bottom, square root and square cancel out, leaving you with z. Square root and square cancel each other out, leaving you with z. Square root and square cancel each other out, leaving you with z. And then just to finish this up, when you have z times itself 3 times, we can rewrite that as z cubed. So 2x over z cubed, since these are all different bases, this is now our final answer. Now for this next one, before we even really think about the square root, there's a lot inside the square root that we can simplify. So you really should focus on if there's anything inside the square root that you can simplify first, such as same bases on top and bottom. You really should do that first before you work on splitting up the quotient inside the square root. So the first thing that I notice is that we have 24 divided by 3. 24 divided by 3 is 8. And then I have this x cubed over x to the 7th. So you might remember way back from chapter 4 that this was the quotient property of exponents. If you have x to a power divided by x to another power, if you have division of two exponentials with the same base, you can simplify by subtracting their powers. Top exponent minus bottom exponent. So that's actually going to simplify as x to the power of -4. And remember, after you subtract, you should always put it in the numerator first, and then if you need to move it to the denominator later, you move it later. Then I have the same thing for the y, so I have y to the 7th over y squared. I have division of two exponentials with the same base, so I'm going to simplify them by subtracting their powers. 7 minus 2 is 5. So then, because I have a negative exponent, what I'm going to do is I am going to create a new denominator. This x and its negative exponent are both going to move into the denominator to become x to the power of +4. Then this 8, which had a positive exponent, did not need to move, so it was left in the numerator. And this y to the power of +5's positive exponents don't need to move, so I'm going to leave that in the numerator. Now that we have fully simplified all of the bases that are inside the square root, now we can focus on breaking up that quotient inside that square root. So now I'm going to break this up into the square root of the top, the square root of 8y to the 5th, divided by the square root of the bottom, x to the 4th. Then I'm going to split apart this product inside the square root into a product of two separate square roots. So I'm going to split that up into the square root of 8 times the square root of y to the 5th, all over the square root of x to the 4th. Now all of these radicals can simplify. So the perfect square factor that goes into 8 is 4. So I'm going to rewrite 8 as the square root of 4 times 2. Then for the square root of y to the 5th, because that power is higher than 2, that means it can simplify. So 2 goes into 5 approximately 2 times, with a y to the power 1 left over. Then in the denominator, because that power is higher than 2, we can simplify it. 2 goes into 4 exactly 2 times. So I'm going to write that as square root of x squared times x squared. Then I'm going to split all of this up into the product of a whole bunch of separate square roots. So we're going to have the square root of 4 times the square root of 2 times the square root of y squared times another square root of y squared times the square root of y. That is a power of 1. I know it's hard to read. And then in the denominator, I'm going to split this up into the square root of x squared times another square root of x squared. Then I'm going to evaluate all of the square roots that I can. Hopefully I'll have enough room. Square root of 4 is 2. Square root of 2 is not going to get any better, so square root of 2. Square root and square cancel each other out, leaving you with y. Square root and square cancel each other out, leaving you with another y. And then because this power is lower than 2, we're going to leave it as the square root of y. Then in the denominator, square root and square cancel each other out, leaving you with x. Then square root and square cancel each other out, leaving you with x. Then I'm going to finish simplifying by multiplying everything that is not in a square root together. So x times x is x squared. And then 2 times y is going to be 2y squared. And then I'm going to multiply any square roots together. So square root of 2 times the square root of y can be combined into the square root of 2y. And then this is your final answer. Now, as far as simplifying square roots, there is what is called a simplest form of a square root expression. So a square root is considered in simplest form when whatever's underneath the square root has no perfect square factors and no powers greater than 1. It is also considered fully simplified when there is no fraction underneath the radical sign. Also, in order to be in simplest form, there can be no square roots in the denominator. So, in the last two examples, we didn't really need to worry about this because they just happened to work out where there was no square root in the denominator. However, if there is ever an instance where you have a square root in the denominator, you must get rid of it in order to call it fully simplified. So the process to get a radical out of the denominator is called rationalizing the denominator. And there are two cases for rationalizing the denominator. Depending on what's in your denominator, you will do different things. So let's say that the denominator just contains a single square root. So here's how to rationalize it. What you're going to do is you're going to multiply both the top and the bottom of the fraction by the square root. Remember, whatever you do to the bottom of a fraction, you must do the exact same thing to the top. So since this fraction here only contains just the single square root of 3 in the denominator, I'm going to rationalize it by simply multiplying both the bottom and the top by the square root of 3. And here's what that will look like. In the numerator, 2 and square root of 3, remember, you can't really simplify something that is in a square root and something that is not, so you're just going to leave that as 2 root 3. And then in the denominator, square root of 3 times itself can be written as the square root of 3 parentheses squared. You can always write a repeated multiplication as an exponent. And then, whenever you have a square root and a square performed together, they are going to cancel each other out, leaving you with a 3 on the bottom and a 2 root 3 in the numerator. Square roots in the numerator are completely okay. It's just square roots in the denominator are not. So since there are no more square roots in the denominator, this is now our final answer. Now, for case number 2, you have more than just the square root in the denominator. So for case number 2, the denominator contains two terms that are added or subtracted. And one, or maybe both, but at least one of them contains a square root. So here's how to rationalize. We are going to multiply both the top and the bottom by the denominator's conjugate. And here's how conjugates work. You're going to take what's in the denominator, in this case, square root of y plus 3. You're going to leave the square root of y alone. You're going to leave the 3 alone. A conjugate involves you taking the sign in the middle and changing it. So I'm going to change that plus sign to a minus sign. So the conjugate would actually be the square root of y minus 3. Now, whatever you do to the bottom of a fraction, you need to do the exact same thing to the top. So I'm going to multiply the top by square root of y minus 3. And then we're going to do a whole lot of distributing. So in the denominator, I'm going to fully FOIL. So square root of y times square root of y, anything times itself can be written as a square. So I'm going to write that as square root of y squared. Then square root of y times minus 3 is minus 3 square root of y. Then positive 3 times the square root of y is plus 3 square root of y. And then positive 3 times negative 3 is negative 9. Then in the numerator, I have to do a little bit of distributing. So we have this square root of 2y times square root of y. Well, I can combine those into the square root of 2y times y. Because they're both in square roots, we can put them together like that. And then the square root of 2y times negative 3, we have something that is in a square root and something that is not, so you're just going to have to leave it as minus 3 square root of 2y. Then let's do as much simplifying as we can. So starting in the numerator, y times y is going to give us the square root of 2y squared, and then minus 3 square root of 2y. Then in the denominator, over here for the square root of y squared, square root and square are going to cancel each other out, leaving you with y. And then if you take a look at the middle terms, these are like radicals, square root of y and square root of y. So we can add them together, but negative 3 plus 3 is 0. So these middle terms should cancel each other out. And then we have this minus 9, which is still there. We have minus 9. Then if you take a look at the numerator, there's a square root of y squared here. So I'm going to separate this into the square root of 2 times the square root of y squared. And then minus 3 square root of 2y is not going to get any better than that. And there are actually no more square roots in the denominator. That's the whole point of this. You should, by the end of this, have no more square roots in the denominator. And then just finish simplifying the numerator. Square root and square cancel each other out, leaving us with y square root of 2 minus 3 square root of 2y all over y minus 9. And as long as there are no square roots in the denominator and all of the existing square roots have been simplified, this is now your final answer. So we're going to try that for each of these. So for each of these, we're going to simplify them by rationalizing the denominator. Remember, square roots in the numerator are okay, square roots in the denominator are not. So for this first one, there are 2 square roots in the denominator, but we can rationalize them both by 1 conjugate. So I'm going to put parentheses around this because we're going to have to FOIL. For its conjugate, I'm going to leave the square root of 2 alone. I'm going to leave the square root of 6 alone, and I'm going to change that middle sign into subtraction. Then, whatever you do to the bottom, you need to do the exact same thing to the top. So I'm going to multiply the top by the square root of 2 minus the square root of 6. So let's do a whole ton of distributing. So let's start with the denominator. So square root of 2 times square root of 2 is the square root of 2 squared. Then square root of 2 times negative square root of 6 is minus square root of 12. Then positive root 6 times square root of 2 is plus square root of 12. Then positive times negative is a negative. Square root of 6 times itself is the square root of 6 parentheses squared. Then let's distribute the numerator. So I'm going to take this square root of 2 and I'm going to distribute it. So square root of 2 times square root of 2 is the square root of 2 squared. And then square root of 2 times negative square root of 6 is minus square root of 12. Then I'm going to do a whole lot of simplifying. So in the numerator, square root and square cancel each other out, leaving you with 2. Now this square root of 12 can simplify. I will leave you guys to simplify that since I am out of room. It actually simplifies to 2 square root of 3. If you need a refresher on how to simplify something like the square root of 12, please see the section 10.1 video on simplifying square roots. Then in the denominator, square root and square cancel each other out, leaving you with 2. Negative square root of 12 plus square root of 12 going to cancel each other out. And then we have this minus. Square root and square cancel each other out, leaving you with 6. And then let's just finish simplifying. So these terms in the numerator are unlike terms, so we're going to leave them like that. But 2 minus 6 is negative 4, and then we're going to call that our final answer. So then for this next one, remember we are rationalizing the denominator because the denominator is what we care about, and we care about getting rid of radicals that are in the denominator. So if you have a square root that's in the numerator, who cares? It's the denominator that we're going to focus on. So I'm going to wrap all of these in parentheses to start. And then I'm going to multiply both the top and the bottom by the denominator's conjugate. So I'm going to leave the 2 alone. I'm going to leave the 3 root y alone. I'm going to change that sign in the middle to a minus sign. Then whatever you do to the bottom, you need to do the exact same thing to the top. And both the top and the bottom are going to require a lot of foiling. So here we go. Let's start with the numerator. 3 times 2 is 6. 3 times negative 3 root y is negative 9 root y. And then negative root y times 2 is minus 2 square root of y. And then, negative times negative is a positive. So negative 1 times negative 3 is positive 3. Square root of y times itself can be rewritten as the square root of y squared. Then in the denominator, I'm going to fully FOIL as well. So we have 2 times 2, which is 4. And then 2 times negative 3 root y is minus 6 root y. Then positive 3 root y times 2 is positive 6 square root of y. And then positive 3 times negative 3 is negative 9. And then square root of y times square root of y can be rewritten as the square root of y parentheses squared. And let's do a whole ton of simplifying and combining like terms. So in the numerator, we have this 6. And then these two terms in the middle are actually like terms because they are like radicals. Since they both have a square root of y, we can combine them into minus 11 square root of y. Then over here, square root and square cancel each other out, leaving you with plus 3y. Since all of those are unlike terms, the numerator is as good as it's going to get. Now in the denominator, negative 6 square root of y plus 6 square root of y are going to cancel each other out, leaving you with 4. Don't forget that minus 9. Oops, minus 9. And then square root and square are going to cancel each other out, leaving you with y. Now since these are all unlike terms in both top and bottom, and there are no more square roots in the denominator, this is now your final answer. So that is it for multiplying and dividing radical expressions, including rationalizing square roots in the denominator. So in the next section, we're going to cover radical equations and solving radical equations. So thank you all very much for watching, and I will see you guys in the next video. Bye-bye.